Hey everyone, I'm Ryan from Motorway. I talk a little bit about not infrastructure as code, but infrastructure is code. A little bit about what I think I mean when I say that. I think some of the benefits that it can have in places in how we treat the technology and the things that we're running. So I said, Ryan, I'm an engineer at Motorway. We're the UK's fastest growing used car marketplace. So we sell cars online. Kind of interesting. I think last year we sold about over £1.3 billion of car merchandise value went through our payment system on our online auction platform. So we're selling a lot of cars across the UK. An AWS community builder. I've been building on AWS for over 10 years and software developer for a bit longer than that. A lot of the things that I'll talk about tonight will have an AWS lean on them, but these concepts and patterns aren't AWS concepts and patterns. I'll just be using AWS as the examples. So what I'm talking about, infrastructure as code, what I mean is that, I guess, given where we are tonight, I suspect most people or everyone is familiar with infrastructure as code in some sense. What is an application? An easy question, maybe a bit loaded. I'm going to use an example, a bit simple. If we think my first to-do app is everyone's favorite example, do something like that, but again, the patterns and concepts that I want to talk about are applicable to everything. Then we've got what infrastructure does your app need? Traditional infrastructure, what is infrastructure? One of my first jobs, I was working at a company that used to manage data centers, and the infrastructure that you manage in a data center is very, very different to the infrastructure that you manage, I think, when people talk about using the cloud and infrastructure as code and things like that today. More with less. There we go, infrastructure is code. So we talked about some examples with what that actually looks like in reality. And what comes next? Gazing into my crystal ball into the future on what I think might happen in the future. There are a few images, so if people can't see, I'll describe them a little bit. The content of the image is not super important. It's just more as visual prompts for things. I think there's a screen at the back, so hopefully things are appearing there for the back. But this is the AWS console with its recently introduced dark theme, kind of nice. Has anyone ever launched an EC2 instance in the AWS console before? A couple of people? Okay, not as many as I was expecting. I thought a lot of hands would have shot up there. But launching something in the console looks like it could be really, really easy. But then the second you want to do it twice or 3 times, or in dev or stage or in an ephemeral environment, you're going to do it wrong. It's not probably, I can almost guarantee that if you clicked everything, prod and dev will never be the same. Competition, there are no prizes other than just self-belief that you are right. Does anyone know how many resources you actually need to create on AWS to launch a highly available load-balanced EC2 instance? Throw the guesses out. It's more than 1. I think it's less than 100. Somewhere in the middle. I don't know how many times I've got to click here because I have my notes, but we've got the actual EC2 instance itself. Got the AMI that you need to launch it with, a launch template that you probably want, or launch configuration if you're that way inclined. We've got an EBS volume, you want to store some stuff on it probably. You probably want to put it in a VPC. You're probably going to need a public subnet and a security group for it. There's a private subnet somewhere. Well, it's in there, maybe it's not. Private subnet, you've got your load balancer, you've got your listeners, you need your targets for your load balancers. You might have an IPv4 address attached to something somewhere. You may have a NAT gateway kicking around there. There's a lot of things, and if you clicked for all of this, you're going to have a bad time. So, we invented infrastructure as code to make this really, really easy. Infrastructure as code allows us to automate everything. Really, really handy. Define what you want once, and then deploy it as many times as you need to, and you can be pretty confident you're going to get the same thing time and time and time again. Cattle, not pets. I think we heard just before that things are cattle and not pets. Cattle's maybe the wrong word, but something that we want to just make sure that we can just, if we don't want it anymore, we're not treating it as a pet, we can just get another one if we need to, we can scale them out if we need to. Then we've got the DSLs, our domain-specific languages. Who's written CloudFormation before?
don't like it at all.
A lot of people don't like it at all. Probably not the first time I've heard that. But it exists, it's super verbose, and it's a DSL. Then we've got who's written Terraform before? About the same number of people, interesting, okay. Kind of cool again, who does have anything on Azure? Bicep or ARM templates? Way less people, okay. And they're all of them share something in common though. They're all really, really verbose to write. Here we go. So I think this is a Bicep or an ARM template. These couple of examples I've got. You're making a service bus, you're making a queue with it. So they're all doing similar things, just with different DSLs on different clouds to get us the end goal. Got a CloudFormation, YAML. Everyone likes YAML. I suspect everyone may like YAML. There's a lot of Kubernetes and things going on here. Maybe too much YAML is a bad thing. Then we've got Terraform. Cool again. Maybe my favorite flavor of the day right now. We've got Ansible. Who's done any Ansible before?
On-premises.
On-prem, yeah, on-prem, on the cloud, same thing, you can run it anywhere, but yeah, Ansible, it can do this very similar things again. So to try and get away from this verbosity, we invented abstractions. We've got vendor-specific abstractions, like AWS SAM templates. Then we've got vendor-agnostic clicks, there we go. So we've got Terraform modules. So SAM templates wrap up a lot of your CloudFormation, let you do some things a little bit easier with CloudFormation. Terraform modules let you do some things in Terraform a bit easier. Writing the IAM policies for all of these is just stuff that I don't think provides a huge amount of value, but you've got to do every time. So wrapping it up into a module makes it way, way easier for people. But we're still writing DSLs. And then we've got things like the AWS CDK. Has anyone used the CDK before? Yeah, a couple of hands. So if you don't like CloudFormation, but like writing things on AWS, the CDK is a really, really nice option for you. And it's kind of getting us a little bit closer to this concept of infrastructure as code. So that TypeScript example, what it does again is not important, but it's creating an event bridge or event bus with a queue and some routing for it. But you're writing it all in TypeScript. You can write it in Python, Java, C#, Go. So there's a bunch of different languages that you can use to write all of this stuff. So you can start to define and write your infrastructure in code. We've even got some third parties that let you do this. So this is a Pulumi example again. Pulumi is just another vendor-agnostic way to write and define your infrastructure. I think primarily in C#, but I think you can use a lot of other languages on Pulumi now too. But this is a C# example of doing the same thing. And again, it's letting us write our infrastructure in code rather than as code. We're quickly seeing things where we might only have infrastructure written in code. So IAC, again, I think everyone on the same page with this stuff, but define our application, define how we want our application to be. With all these DSLs and the declarative programming languages or DSLs that we're using for, we're defining what we want our infrastructure to look like. We're still writing the actual code that's running in the cloud eventually at the other end of it, particularly with things like EC2, Docker, and even Lambda. We're writing what we want to run inside there, but we still got to use DSLs to define how it operates. Everywhere declarative like YAML, then we start to see some abstractions over the top of it, and then we even get into a bit more imperative programming languages, C#, TypeScript, Go, Java, all of these things to do a similar thing again. But fundamentally, all of these things translate all the way down to CloudFormation or whatever it is that we're running in the end. What is an application? So I mentioned I want to talk about infrastructure is code. Most of the things that we are running, we're writing applications. That could be web apps, that could be on-device, low-level things. That could be code that's powering my clicker, your TV, your phone. I guess a lot of people might be working with web applications, so APIs, websites, databases, things like that. I'm going to use a really simple example of a web API that might have a database behind it. And again, these patterns don't have to only apply to something simple. You can do a lot of really powerful and really complicated things with these. But if we do think about just a simple web API, there's a few things that you're probably doing. You've probably got some routes, get users, add, order, update, user address, things like that. We're going to have some validation on those to make sure that we're always validating our payloads. Always validate your payloads. Don't trust things on the internet ever. You might want to do some data transformation on it. Then we're probably storing something in a database and sending something back to our clients at the end. Again, very, very simplified version, but generally a lot of web services APIs do things similar to this. So validation and routing. So I want to focus a little bit more on the code versions of these infrastructure as code languages, and we'll start to expand and dive a little bit more into them. So if we just want our routing and our validation logic, this is an API gateway. So API gateway is Amazon's managed services for API gateways. It's actually one of the really more easy to understand name services that they've got. But with this one here, up at the top, I don't know if you can see it or not, so I'll talk through it a little quickly, but up at the top, we've got an open API schema. People, I think, generally might want to define their APIs in Swagger using open API specs so we can visualize things, understand and document our API, code gen things if we need to. So we can actually give API gateway, and in this case, I'm using TypeScript as part of my infrastructure definition to give it the open API schema definition. And then down here, I'm adding a method. So I'm creating an orders API and a users API, and I'm adding a get users method onto it, and I'm passing in the schema validation that I want here. So when this is then on the internet, someone sends a request to my API, I'm not going to have any code running. API Gateway is going to do that routing and that schema validation for me. So it's never going to hit any application tier that I've got. Likewise with the post method, I want to add an order somewhere. If you're not passing the order that you want to create in the correct schema shape definition, it's going to throw an error, and you're not going to get even anywhere near my application. It's all happening, someone else is doing it for me. I'm using code to define how I want my application to run, but I'm not actually running any logic in my application itself. And we've got a database integration. So there's a little bit of code manipulation that's happening in here too, but you're going to want to write this information to a database. Services that I think are born on the cloud work really, really well together when you're running things on the cloud. And taking advantage of the best things that different clouds can offer you can really, really improve and simplify and make things in some ways faster and cheaper to run. So in this example here, again, this is still using CDK, but you could use Pulumi, you could use TypeScript, you can use C#, there's CDK for Terraform you could use. All the patterns apply and can work across different clouds. But in this particular example, on my up at the top, I've got my user root, my get users method, and then I am doing some code manipulation here. So I've got my I've got an integration type, and I've got an integration request part, and I want to get users out of this database. And Amazon and API Gateway itself for me is going to go off to the database, get the user out of the database, transform it based on how I've defined my code, not running my code, but based on how I've defined my code, and return that back to the user. So again, there's another example now. We've got our API, we've got our schema validation, we've got our routing, we've got our code transformation and our database integration, and we're not actually running anything yet. All we've done is define how we want our code to run. And then it's exactly the same for database writes. So if I want to add an order to my database, I've got my post method up at the top, and I've got my request template here. So this is the template for how I want this request to happen inside the gateway, writing this information to the DynamoDB table. You can do some code down about halfway down. I've got this request template, it's where the transformation is happening. It's taking some inputs from my request. And because this is validated, I know that this is validated against my schema. I know that these properties are safe to use and they'll be there. And I can then just start passing them straight into the database, Dynamo in this case. But again, everything's taken care of for me. I don't have to run anything, I don't have to patch anything, maintain anything. So what infrastructure do I have here? I mentioned worked in a company that's managed a data center before. I certainly don't have any hard drives, racks, and network cables to worry about here at all. I think on the cloud we don't have to worry about that anymore. But I don't have any other infrastructure to run. I'm not running a Kubernetes cluster. I'm not running a Fargate task. I'm not running a Lambda function. I'm not running any code at all. I've got an API gateway, I've got an API schema, and I've got a database. And these resources are really, really small to create. back at the start with that EC2 example. EC2 I think is at the far extreme end of the spectrum, but there are tens of resources that you need to create for that to work. And with this example, I have to create 3 resources, maybe 4 or 5. There's some routes and there's a validator you've got to create, but there aren't many going on here. So I've drastically simplified what it is that I'm having to provision, and I've drastically simplified how it is that it runs when I've got it. So this is the infrastructure that I've got, the code that I've got. There is no runtime code, or there are, but it's someone else's. The cloud, everything else, serverless, anything like that, it's someone else's computer. There is a computer somewhere, and there is code for it. In this case, it's just not mine. I'm not going to get any dependable alerts. There is no maintenance to be done on it. There is nothing that goes out of date. There are no vulnerabilities. Log4j happens. I don't have to go patching everything. It's sleep easy at night, knowing that I've told Amazon how I want my code to run, and it goes away and runs it for me. Although not quite. I do have code. I've got a whole bunch of TypeScript code or C# code, Python code. I've just got all of that at build time and deploy time. There's none of it actually at runtime. So we do still have some code. I might still have to update something somewhere to patch my deployment pipeline, but none of it's ever going to get into production. And I don't deploy any code to actually run. So I do have to maintain CDK code in this case. I mentioned you could use CDK for Terraform, you could use Pulumi. There's a bunch of other providers out there that do really, really similar things. And I need to maintain my API schema. So it's drastically smaller than it may otherwise be. But when should you use this? It depends. This it depends comes with a huge, really, really scary dragon, I think, anyway. Some of this stuff is really, really cool. It's really, really interesting. I think it does work really well for some use cases, but not all. As the complexity of the application grows, some of it can be a bit harder to manage. You can't run this locally, right? This is you have no code to run locally, someone else is running it for you. So you need to really make sure that you've a good feedback loop process with development environments. Ephemeral development environments or just a long-running dev one can work really, really well. Integration testing rather than unit testing working well. And then you still have some DSLs and specific things to learn. Whilst it's written in TypeScript, how API gateway works and is configured, you still have to learn how the database works, you still have to learn things like that. So there are things that you've got to consider and think about when going down this path. So applications as infrastructure, we've now got to a point where our infrastructure is our code. Our infrastructure that we've written in TypeScript is the only code that we've got to worry about and maintain. Our application is now the code. Our infrastructure is the code that we're using to deploy these applications. So we define the code that we define how we want the code to run. We don't actually define the code that runs. It's all a build and deploy time concern. There's nothing that's ever actually running in the environment. But it can be harder to test, a little bit harder to operate. It does come with some, I guess, learning curves in some places. So yeah, something to keep in mind, bear in mind there. So what's next? So we've got this, it's kind of cool, kind of interesting. I'm not sure that this is the end game for some of these things. As we move further and further towards these patterns and processes, I think a lot of the dragons that exist with them can start to really be optimized, improved, feedback loops, sharpened up, things like that. So there are way more cloud-specific integrations. In this specific example, I had an API that writes data to a database, some data manipulation in the middle. On AWS, on GCP, on Azure, on all the large public clouds, there's a lot more that you can do. So you can have an API gateway with validation and routing, writing to a database with a change data capture stream coming off the back of it, going through an event bridge pipe with a data transformation, going off to a step function that then does a bunch more tasks, interact with third-party APIs, manipulates more data, and publishes an email or a text message to someone at the end. And all of those words that I used there all come with different DSLs that you can write in TypeScript, but they're all different again. So there's a whole bunch of cloud-specific integrations that you can use and do. You've just got to learn each one of them individually, which isn't the easiest to do, I'd say. I'm not always sure it's the best use of time. Everyone knows the primary language they work in: Go, TypeScript, Java, C#, whatever. So where might that get us to? And I think this might be something that looks a bit more like the future, where again, we're defining how it is that we want things to run, but at this point it's becoming even more agnostic. So there's I guess a startup, probably still a startup, a company called Winglang, and again, I don't work for them, I don't run this in production, but I think it's a really, really interesting look at where I think some of these concepts might be going. But Winglang lets you define things. This example here is an API, but it lets you define things, define how you want them to run, but you don't know where it's going to be running. You tell it where to run, but you can take this same snippet of code and you can deploy and run it on AWS, you can deploy and run it on Azure and on GCP if you need to. And Winglang itself will take what you define, it will translate it into those public cloud specific features, and will actually go off and run them for you. And I think that can become really, really powerful, because Winglang, I guess, almost started from scratch with some of this, that you can run this locally, and by writing this, you do start to see the architecture diagram that you're going to get out the other end of it. And you do get to see what's going on under the hood, and you can understand where it's going, and you can test it, and you can get faster feedback loops with them. So I think something like Winglang might be an interesting future for how infrastructure Azure code is going, and we can just start to define how we want our applications to run in languages. Again, this is another language you've got to learn, but you can define how you want your applications to work, and just let the cloud figure out how to actually make them work. I think when we get there, it becomes a really, really powerful paradigm, because the cost efficiency can massively go up. I think it can become much more green and eco-friendly. That the cloud deals with the scaling, and they're dealing with on a huge scale, so they can really start to drive out the optimizations, like almost right the way down to compute cycles and memory allocation. So there are some really, really, really interesting benefits that you do get with doing something like this. So it's just a quick summary. So we've got infrastructure as code, define how we want to define our applications and our code that we've got to run. So we can then move on and think about just infrastructure as code, using our favorite programming languages to define how we want our applications to run, and handing that off of the cloud to go and do it. Then we've got things like the future, where I just want some code to run. I don't really care how it runs, who runs it, how it scales, any of this stuff. I just want it to do this. And give it off to some cloud to go off and do it for you, and remove all of the complexity that comes with it. Thank you.